I made an animatronic glow-in-the-dark skull that holds a secret in its brain, and I'm going to show you how I made it. This is my latest project for Halloween. This is my candy skull. It is an animatronic glow-in-the-dark skull I printed in glow-in-the-dark PLA from Bamboo Labs. As you can see, there's a little hole there, and there's a distance sensor. And when it measures a certain distance, it does this. And then when you get a little closer, it does this.
Eat my brain.
Oh, don't mind if I do, Candy Skull. My favorite. Kit Kats and Reese's Peanut Butter Cups. And that's my candy skull. It's a simple idea, but there were a lot of things I had to work through on this build, and I'm gonna take you through it. All my ideas start off as a drawing, and these are my beautiful drawing skills. I didn't want to design my own 3D skull, so I found this cool human skull that MakerBot scanned from a real human skull on Thingiverse. Then I found someone who already made a candy skull out of the MakerBot human skull scan, and this was going to be a great starting point for me and my project and save me a bunch of time. I imported those files into Fusion 360 and went to work on altering what I needed to make my candy skull. I needed to put a hinge on the back. I needed to put a servo holder for the skull cap servo and a servo holder for the jaw servo. I had to create the stand and base for it. And it took me a bit to learn how to interact between mesh files and solid bodies in Fusion, because at first I converted this skull into a solid body and it basically froze my computer up. It was very difficult for it to work with. So I left it as a mesh body and learned how to interact and alter things in Fusion 360 for my project. I will spare you all my trial and error and show you the final prints. The skull came out beautiful. I did print one in regular white PLA before I used the more expensive glow in the dark and made sure everything worked before I printed it out in the expensive stuff. I used regular supports on the skull and skull cap because I found they came off easier from inside of a dome type shape. It was a little difficult getting all the support material out of the holes and little crevices, but it is doable. Use some pliers and you can use an X-Acto knife to help with the finer details. You're probably going to also want to use a little hand drill to re-drill the holes and push out the support material for the hinge. The skull cap is printed essentially on supports because the hinge dips below the edge of the skull cap. Again, use that X-Acto knife to get all the support material completely off the edge. You'll notice a flat rectangular piece to print out. I printed this out on a smooth build plate. Because the skull cap printed on supports, it really creates a rough surface. By gluing this piece into the skull cap, it'll create a smoother surface for the servo arm to push up against. I printed out the jaw with tree supports. It just works better on the jaw and comes off super easy. Don't forget the X-Acto knife and all the little bits that get left behind and little burrs from the supports. For this stand, I used a matte black PLA from Bamboo, and it came out really good, especially with the smooth build plate. I was really impressed with how it looked. The wire hole for the jaw servo is a real pain in the butt. You're definitely going to want to use an X-Acto knife and even try to push a drill bit or wire hanger through the hole to get all the material out. I love threaded inserts. I used M2 screws throughout the entire project, so you're going to need some M2 threaded inserts for this. Then install those same inserts on the jaw where the servo arm attaches to the jaw. It makes it so easy to attach that servo arm that comes with your servo right to the jaw. Let's dive into the electronics. This diagram is the final version and connections for what is inside the candy skull. I started out with an Arduino Nano for this project, but I learned that the Nano wasn't going to work, and this is what happened when I tried to combine servo motion and audio. The servos didn't work when I needed them to, and the audio was getting a lot of noise. That's when I realized I needed a separate piece of hardware to control the servos, and so I went with the Adafruit 8-channel servo control PWM board. The form factor of this board was Adafruit's Feather form factor, so I decided why not just use a Feather
microcontroller to control everything. I realized I had a Huzzah 32 feather board lying around, so I decided to use that rather than buy something new. For the rest of the electronics, I'm using a DF mini player with a speaker, 2 micro servos, a couple red LEDs, a buck converter, a time of flight distance sensor from Adafruit, a barrel jack, and an on and off switch. Let's start preparing all the electronics. I realized that the servo wires were going to be too short for my purpose, so you're going to have to solder on new wires to your servos. First, take out the 2 screws, peel the stickers back so you can take off the cap off the back and expose the circuit board with the wire connections. I just cut the original wires really short and then soldered new wire onto it. Make sure the wire you use for this is a small gauge and flexible wire. I measured out 21 inches of wire and cut them off at that point. Screw the back cover back onto your servo, and remember to do that with both servos. Then prepare your red LEDs with the same amount of wire. Red goes for the positive terminal and black goes for the negative. Make sure you get these right, otherwise your LED won't work. Once you have your long wires installed on your LEDs and servos, you can start threading them through the skull. I started with the jaw servo wires and then secure your servo with 2 M2 6mm screws. Thread the wires into the main cavity of the skull and then thread them through the hole in the bottom, which will eventually go to the base. Then you can install the skull cap servo. There is a screw hole to secure the servo in there, but it's really not needed and it's a real pain to try to get that screw in, so I suggest just skipping that screw. Then just run all the wires through the hole in the bottom of the skull, and you can tape all the wires to the inside of the skull to hold them in place. Next, attach the servo arm to the 3D printed part that pushes the skull cap open. No threaded inserts needed, just screw the M2 screws right into the 3D print. Then you can install that arm onto the servo that controls the skull cap. You're definitely going to want to screw this into place with the screw that's provided with your servo. A little trick to help you thread the LED wires through the eye socket tunnels is to use a piece of monofilament fishing wire and tape that to the ends of the LED wire and then pull that through the tunnels. It works a lot better than just trying to thread the wires through the tunnel. After they've been threaded through, I put some tape on the pairs just so I know which two belong to which light. Then use some hot glue to glue your LEDs into the eye extenders. Once you have both eye extenders and LEDs glued into place, you can glue on your eyeballs. To give the support pipe a nice snug fit, I used some gaffer tape around it. You could use masking tape. Then thread that whole mess of wires through your pipe and into the base. And fit the pipe into the skull. Careful not to pinch any wires in the process. Time to attach the skull cap. Just thread a piece of filament through the holes in the hinges and trim off the excess. I provided my audio files for your use, but if you want to record your own sayings, go ahead and do that. I just used GarageBand.
Eat my brain. Boo.
Prepare your servo control board by soldering on all the male headers so it can stack onto your Feather microcontroller board. Solder your voltage in and ground to your buck converter to give your servo control board power. Then solder your servo wires onto channels 0 and 1 of the servo control board. Next, solder on all the wires to your distance sensor. Then solder your clock and data cable from the distance sensor onto the servo control board, and that will pass the signal onto the microcontroller. Then solder on the capacitor. I control the LEDs for the eyes using a PWM channel on the servo control board. So attach a 220 ohm resistor onto the ground through hole for channels 3 and 4 of the PWM servo control board, and then attach your ground wires from your LEDs to these resistors. Then solder the positive wires of your LEDs to the PWM through hole on each channel. Now it's time to prepare the DF Player Mini. I installed it on a small piece of proto board. This makes it easier to solder things to it. After I pushed it onto the proto board, I bent back all the pins. This secured it into place, but it also did two other things. It gave me more space to solder wires onto the pins, and also it allowed me to put solder on the front side to connect with those pins, so I could solder either on the front or the back of this proto board to make my connections. Then I soldered the speaker onto the speaker pins. Then I soldered wires onto the receive and send of the DF Player Mini for the serial communication connection. Then solder a wire on the voltage in pin and also a ground wire, and I also grounded the two pins on the back. Next comes the capacitor, positive to positive, negative to negative. Then solder your send and receive wires from your DF player to your servo control board. Then solder all three boards directly to the voltage out on the buck converter. All the electronics are ready to install. I forgot to put my threaded inserts in the base, so I did that before I finished up. Thread and push your power switch into the hole, and place all your electronics inside of the base, and then glue your speaker and distance sensor into place. The switch is going to interrupt the positive voltage coming from the barrel jack. So one terminal from the switch goes to the positive pin on the power jack. Then the other pin on the switch goes to the positive voltage input on the buck converter. And then the negative pin gets soldered to the negative input on the buck converter. All the electronics are in, and it's time to put the bottom cover on. I used 6mm M2 screws to attach the base to the bottom, and then my son ate all my candy, and then I used sticky nubs on the bottom for traction so it wouldn't slide off tabletops. It is time for your first test. Fill the candy skull with your favorite chocolate or candy.
I wanted it to be filled.
Turns out I had a candy thief on my hands.
The moment of truth. Do you think it's gonna work or fail? Flip the switch on the back. The audio isn't working.
Turns out there was an error in my code, and that's why the words were not synced with the jaw movement, but I fixed it, and now it is working perfectly. Looks like I found my candy thief. Speaking of the code, here's the final code, and the link to it is below. Here are instructions on how to work your candy skull. First, fill the entire skull with your favorite candy. Close the skull cap, then plug it into electricity, and turn it on. Set it on a shelf this Halloween and scare your friends.
Eat my brain.
Remember, it's glow in the dark, and it looks really spooky when you turn the lights off.
Eat my brain.
So that is the candy skull. I hope you make one for Halloween. If you do, take some pictures, send me them. I would love to see your creations. If you liked the video, hit the like button, subscribe, and I'll see you in the next video.